Okay, moving on to 2.3. I'm going to remind you how to graph these inequalities because graphing is going to play a huge part into 2.3. We are looking at a whole new concept with inequalities. We're adding to just a one inequality statement. So we have to know how to graph those and how to read those graphs. So in that first one, it says x is greater than or equal to 4. The number itself is going to be your starting point. So we have to put a dot on that 4. Now that inequality sign tells you what type of dots. Any answer needs to be shaded in. So since it's an equal to, I need to put a closed circle on that 4. Now, remember, we always want our variable first. So when our variable's first, there's the arrow rule. Since my arrow is pointing in this direction, I'm going to shade everything to the right, and you can kind of see that the arrow at the end matches the arrow in your inequality. Now, on number 2, you know your starting point because you can physically see the number. We have to switch this around in order to graph. It is very difficult to read and wrap our minds around what the answers actually are in this order. So I'm going to rewrite my x and my 9. I'm going to go back to my original and look at my sign. It's eating the 9. So I'm going to make it eat the 9 in my second one. Again, we already knew that we needed a dot on your 9. Since there is not an equal sign, which means it is not an answer, it has to be open. Now that we can look at this arrow, because my x is on the left, my arrow is pointing to the left, which means you're shading everything in this direction. Also, these lines never end, so just because we don't see a number doesn't mean that it's not there. So in this lesson, we're going to be looking at compound inequalities. A compound inequality is 2 or more inequalities joined together with an and or an or. So here's the thing. You guys know compound words from LA. Snowflake, peppermint. Okay, it's 2 words put together. So essentially that's what they're doing here. They're going to take 2 inequalities and combine them. But unlike LA, we have to have a word to combine them. And there's 2 words. We have an or statement and we have and statements. So here are some key concepts that we need to look at. It says, to be a solution of an or inequality, a value has to make only one part of the inequality true. There's only one way to write this compound or inequality. So here's how we can write this. It has to have the word or. If you don't put the word or, then I have no idea what you're talking about. Okay, so the word or has to be in there. So the way that I describe or is if I go to McDonald's and I want chicken nuggets or a hamburger, technically you could go up to the register and get me either one. If you walked back with chicken nuggets, I'd be happy. If you'd walk back with a hamburger, I'd be happy. So that's the same way that this is. So we do have 2 inequalities, but the answer that you choose only has to satisfy one. But again, we still have to represent them. So if you look at my graph, I have an open dot on my -1 because it's not equal to, and my arrow is pointing to the left, so I shade to the left. So right now, this section right here represents this inequality. Okay, I also have a bubble, oops, sorry guys, on my 6, because there's my 6. It is closed because the equal to, and it's shaded to the right. This inequality graph is working with my orange box. So here's the thing. If I pick something in this shaded section, it's going to be right because it fits my blue inequality. If I pick something over here in my orange shaded section, it's going to be right because it fits my orange box. Only one of them has to be true in an or situation. Okay, here's our next one. To be a solution of an and inequality, it must make both parts true. Compound and inequalities can be written in both forms. So if you look at this first form, it has the word and in it. Just like over here, we had the word or in it. But and can also be written in a squished format. So what they do is they take the variable and they put it in the middle. They then put the numbers in order of least to greatest. So 0 is the least, greatest is your 3. And then they look at those signs, kind of how I did number 2. Since my sign, I just wrote that backwards, guys. Let's try that again. Since my sign is eating my x, you can see down here that the sign is eating the x. On this side, my sign is eating my 3. You can see that that sign is eating the 3. So, looks a little funky, but it still works. So here's the thing with ands. Again, I'm going to go back to McDonald's. If I go back to McDonald's and I tell you I want chicken nuggets and a hamburger, then you best be walking back to our table with both of them. Because I am not going to be happy if you walk back with only one of them. So if I tell you and, that means I want both items. So if you look, my graphs go together this time. It isn't overlap. And means where are they overlapping, because that's going to make both of them true at the same time. So if I look at this, I have a dot on my 0. It's shaded to the right, just like my arrow says. I have a dot closed on my 3. It's shaded to the left, like my arrow states. If you notice, my line, my shading does not go past the 0 to the left. It does not go past the 3 to the right. The only answers we are going to have are going to be in the middle of those 2 dots. It does also include the 3 because it's an equal to. So the first part is we need to be able to identify if it's a solution by being given a number and knowing the and or situations, or by looking at a number line. And that's what these next 3 do. Okay, so on this first one, they want x to be a 4, and it's an or situation. So it only has to work in one of them. So let's look at this. I'm going to plug this in. 4 is less than or equal to a -3. Well, that's not right. Okay, but we're not done because it's an or. There's an or in between. So now I have to plug it in the other one. 4 is greater than 2. Since 4 is greater than 2, this is a solution because it's an or. I either want chicken nuggets or a hamburger. It works in the hamburger, so I'm okay. Now this next one, it says and. So that means when I plug in a 4 again, it has to work in both. I need both of them to work because I want the chicken nuggets and I want the hamburger. So here we go. So I have 4 is greater than or equal to a -3. Well, that's right. And 4 is less than 2. Since 4 is not less than 2, this is not a solution. And it has to work in both. So, first thing that you need to be able to identify and pay attention to is the word in the statement. I don't have to give you that statement. I do because I'm nice. But you also have to be able to identify the graph. In an and graph, they're going to come together. So your shading is going to be in between your 2 dots. On an or situation, I'm going to slide this down a little bit. They're going to go opposite directions. So ands come together, ors go out. So you have to be able to recognize that with the graph as well. So here's the thing. Could I take all these numbers and plug them in? Yes. I'm going to put some dots where they tell me, and we're going to check them if they're in the shaded area. So the first one is a -10. If I look at that -10, is it in the shaded area? No, it's not. So I'm going to move on. My next one is a -3. My -3 is right here. Well, that is a shaded dot. Shaded dots are answers, so that is a true answer. My next one is a 5. 5 is all the way over there in my orange. 5 is not in that shaded area, so I'm going to move on. My next one is a 0. 0 is inside that shade, so I'm going to check it. X is a 1.5, which is going to be right here in front of that open bubble. So I'm going to check it. The last one is a 2. Your 2 is that open bubble. Since it's open, it is not a solution. Okay, so now here are our next ones. Now you have to be able to graph them. Again, you have to know that ors are going to go out and ands are going to come in. You have to know that. Ors can only be written with an or statement. Ands can be written with the word, or they can be smushed. So let's start with our ors. When I graph my ors, I know they're going to go in opposite directions. So I'm going to put a closed dot on my 0. It is pointing to the left, so I'm going to shade everything to the left. So my orange only works in that first one. Now I'm going to go to my other one. My other one is a 2, and it's going to be an open bubble because there's not an equal to. My arrow is pointing to the right, so I'm going to shade everything to the right. My green one only works in that second one. I only need one of them to work. You can pick answers from the orange, we're good to go. You can pick answers from the green, you're good to go. Okay, so now let's look at my and. Your ands are a little bit more complicated because you have to be careful. What I like to do is I like to put my 2 bubbles first. I know that I'm going to put an open bubble on my -1. And I'm going to put an open bubble, which I know is kind of hard to see, on my 3. Because it's an and, they should come together and overlap. And this is where you have to be careful. So I'm going to slowly draw my shading to the right. And then I'm going to go to my 3 and slowly draw it to the left. I do not want to go past my bubbles to the left and to the right because then we would not have a correct answer. Okay, on number 6, I separate. It's easier for me to see. That's just a personal preference. So what I do is I'm going to cover up that back inequality, and I'm going to rewrite this. So instead of my -4 being here, I'm going to say x and -4. If I go to this, it's eating the x. So I'm going to eat the x. Now that I'm done with my -4 and that symbol, I'm going to cross it out because there's my other one. So here are the 2 inequalities. I'm going to box them in so you can see them. There's 1, there's 2. And now I'm going to graph them. So I need a open bubble. Again, I'm sorry, estimate where your -4 is. I need a closed bubble on my 4. And then again, because it's an and, ands can be written 2 ways. We don't have to see the word. They're going to be smushed together. Okay, be careful. This one looks a little bit odd, but that's okay. So let's go to this one. I know I need an open bubble. I lied. I need a closed bubble on my 5. My arrow is pointing to the right, so I'm going to shade to the right. I need a closed bubble on my -6 as well. And if I look at that -6, it is pointing to the left, so I'm going to shade to the left. Since it has the word or, I already underlined it, they should be going in opposite directions. Okay, so here are some more to practice with. So I am going to start graphing these to see what happens. I'm actually going to graph these above, and you're going to see why here in a second. So I'm going to put an open bubble on my 4, and I know my graph needs to go this way. I'm going to put an open bubble on my 6, and my graph also goes this way. For an and, they usually go together. This is going to be a special situation. Remember, we want the overlap. I want both situations. So if I follow my pink pencil and I start here, are they overlapping? They start overlapping right here at that 6. So because they don't start overlapping here, this whole orange part is not going to go on my graph. I'm going to put an open bubble on my 6, and I'm going to shade to the right. So we are using the green graph when it's a special situation. So this is a special and. Okay, on this next one, this is an or. So let's see what happens. I'm going to graph above so we can see what's going to happen. So I need an open bubble on my -3. This graph is way better. And I'm going to go to the left. I need a closed bubble on my 1. I'm also going to go to the left. So in this one, we need the situation that's going to satisfy both of them the entire time. So when we do this, if I look at this blue one, it's not going to satisfy them both the entire time. We need the longest one. So on this one, we're going to use the closed bubble on my 1, and we're going to shade all the way to the left. So these are kind of opposite. On the ands, we always pick the shorter one. On the ors, we pick the longer one. Okay, so here's another squish. So I'm going to separate it. I'm going to cover that guy up. So I have x, I have -5. It's eating this -5, so I'm going to keep it eating that -5, and then I can cancel that out, and there's my other one. Again, this is an and because it's squished. I'm going to shade above again. So I have an open bubble on my -5, and we're shading to the left. I have an open bubble on my 2, we're shading to the right. So remember, with an and, we want the overlap. Do these two graphs overlap? No. So this is actually no solution. So this is also a special. So these are both special ands. Which then I guess you guys can really assume that this is going to be a special or. Well, let's see what happens. Okay, so I'm going to put on my 5. I'm going to put an open bubble. And it wants me to shade this way. And I'm going to put on my -2 a closed bubble. And it wants me to shade this way. Remember, you want the graph that's going to represent all of your situations, which means I have to put both of them on there. If I'm going to put both of them, that means every single thing is going to be shaded in. So in this case, this is infinite solutions. So here's the thing. Your ors, they can be normal. They can be special. Your ors are the only ones going to be infinite. Your ands, they can be normal on the front. They can be special. They're the only ones that can be no solution. Okay, last part of this first video is going to be part 3. And now we have to write these inequalities. Okay, we only write normal situations. So when you look at these, you should be able to tell which ones are ands and ors. The biggest thing here, you have to put the words. So on this first one, for example, we're going to put the word or in the middle because it goes apart. And then I also start with our variables. We want to start with our variables first. So I'm going to put an x and an x on each side. From here, I'm going to go left to right. See, my first dot is a -5. It is shaded to the left. So I need my arrow pointing to the left. Since it's a closed bubble, it's going to be equal to. My next bubble is right here at a -2, so I'm going to put -2. It is shaded to the right, so I'm going to drop down an arrow that points to the right. It is also a closed bubble, so it's going to be an equal to as well. My next one is an and, so I'm going to put the word and. I like just using the words, again, personal preference. They're my variables. My first bubble is a 10, so I'm going to put 10 first. It is shaded to the right, so I'm going to put an arrow that's to the right. And it is not equal to because it's open. My next bubble is my 20. If I look at my 20, it's going to the left, so I'm going to put a left arrow. And there's not an equal to because it's also open. I have an and. We have an or. Go ahead and fill these in. Pause your video. I'm going to write my answers. I'm not going to talk about it because I want you to try it on your own. This next video will be part 4 and 5.